As an aspiring developer, you'll likely encounter situations where you find yourself frequently transforming data from one type to another, repeating code like the same function definitions and so on. As a result, you might just ask yourself, isn't there a more effective way to do the same thing so that I don't have to? By watching this video, you'll discover some of the higher order functions provided by Swift to manipulate collections of data. More specifically, you'll learn about three higher order functions that some of the Swift collection classes provide. These are map, filter, and reduce. Suppose that while developing functionality for the Little Lemon app, you decide to develop a function to print all the recent customer payments. Only payments of $60 or more should be considered, and the final result should be a string. How can this be achieved? The answer is a few lines of code using Swift's array manipulation methods. As you might recall, higher order functions are functions that can take on another function as an argument or return a function. Higher order functions can also be useful when you want to manipulate collections of items. The array class in Swift has three such functions, namely map to transform each item in the collection into a different one, filter to remove certain elements from an array for a given condition, reduce to return a single accumulated value using all the values from the array. These functions use closures to enable you to pass on functionality and describe how the data should be transformed. Imagine you have to convert all the numbers inside an array to text representations. The map function is very convenient in this scenario. It can take a closure that transforms each element of an array to the string, producing a new array containing numbers in string format. The previous example could be implemented using even less code by taking advantage of something called shorthand argument names. Swift automatically provides shorthand argument names to inline closures. This means that you can refer to the closure arguments as $0, $1, $2, and so on. Taking the previous example where the map closure has only one argument, you can use the shorthand argument $0 to represent it automatically and achieve the same result. The filter function is best used when you only need to get the numbers from the array that pass a certain condition. The closure of the filter method determines if an object will be added or left out of the resulting array by checking if each element is more than 60. And the shorter version of the same example refers to the closure argument using $0 to achieve the same result. The reduce method is used when you need to combine all the elements in the collection to get the final single result. The call to reduce takes an initial value and then a closure defining how to combine array elements using it. In this example, the closure inside the reduce function has two elements to track the sum that has been generated, as well as a current element of an array that adds to the full current sum and returns the result. Unlike map and filter, the reduce function closure uses two arguments. Using shorthand argument names, they can be referred to as $0 and $1. So far, you've been tasked to get financial data about customer spending. Let's now explore a demonstration of how you can list all of the customer payments and print them in a string to be displayed on screen with the condition that the payment amount is more than 60. I start by defining an array that holds the payment amount values that customers made. I call it payments array and insert values to represent each payment. I also want to make sure that I include values that are less than and more than 60. Next, I will demonstrate how to remove all the values less than 60 from the original array so that only numbers above 60 remain. To do this, I use a filter method. I define a resulting array constant called large payments. Its value will be the result of calling a filter function on the original payments array constant. To only select values over 60, I write a condition inside the closure that $0 constant should be more than 60. This results in the large payments array containing only numbers above 60. I verify if that is true by writing a print statement to display the large payments array in the console. By running the project, I can check that the result is as expected. Next, I want to convert all the filtered numbers to strings. To do this, I use a map function. Firstly, I declare a new constant called filtered payment strings that holds the result of calling a map function on the previous filtered payments. Inside the map closure, I use a string constructor to indicate that the values should be presented as a string. I print the filtered strings array and run the project again to confirm that it now contains strings representing numbers. Finally, to combine all the strings into a single object, I use reduce on the strings array. I declare the last constant called final list string. Then I initialize it by calling the reduce function on the strings array defined earlier. Next, I pass an empty string as an initial value in the reduce function call. And as the closure has two arguments, I can just add them together by adding $0 arguments to the $1 argument of the closure. As the $0 argument is the previous result and the $1 argument is the current element, it produces the final combined string of all the values inside the strings array. For the strings not to be compacted together, I insert a comma string separator between each number when adding them up. Now when I print the final string and run the project again, I can confirm the final string contains a list of numbers separated by commas. In this video, you've learned that Swift Array provides three convenient higher order functions to manipulate data called map, filter, and reduce. You have also learned that a map is used to transform the object into another object, and the filter is used to a new array with only the values that pass a provided condition. Finally, you have discovered that reduce can be used to combine all the values inside an array into a single object. You have also learned how all of them could be used to achieve a certain example requirement.